Hi guys, this is just a bit of a follow-up on a circuit that I posted not so long ago on the forum, and a couple of videos I've done on it. I called it the super simple solid state. Yes, a lot of S's in that one. At the moment that's what we're hooked up as. I've soldered a diode onto our charge battery positive, so I can just take it off and hook it on this side, and this yellow lead I can just bridge to our charge battery negative, so we can swap from this circuit over to a normal SSG solid state circuit, just so we can see the difference. So on my circuit at the moment it's drawing 19 milliamps, and we have a very good conversion rate here. We are set on DC, we are zeroed out. Our time divisions are 0.2 milliseconds and our volt divisions are set on 5. So as you can see, our on time is about 2 or 0.22 milliseconds, and our peak voltage is about 12.5, which is the voltage of the battery. Our return voltage, or the flyback that's going back to our charge battery, and of course this is the coil collapsing and dropping the voltage in the opposite direction so we can charge our batteries. At the moment, I'll just move this across a bit so we can get an accurate reading on that. 5, 10, 11, 12, 13, 14 volts peak, and it is about 0.22 milliseconds as well. So it actually looks like it's putting out more than we're putting in. However, this does look a little tiny bit wider on the on time. Maybe it's 0.23 seconds, somewhere around there, but it's also very close. So what we're going to do now, just to recap that, we're getting our 12.5 peak voltage into the coil, and it's dropping down to about 14 volts below zero, or in the opposite direction, which is what goes back to our charge battery, and it is 19 milliamps. So what I'm going to do now is just disconnect this, and we're going to hook it up SSG style, simply by doing this. And well, the system's gone off. Let's see if we can start it again. So maybe got to get going sometimes. There we go. So it's up and running. Now here you can see we're drawing 23 milliamps now, so we're drawing more power, which is apparent on the scope because it's staying on for a longer period of time. It's about 0.42 milliseconds now, and our peak voltage there is up to 14 volts. And the charge going back is peaking at 15 volts exactly, and it's on for 0.4 of a millisecond, or the coil is off for 0.4 of a millisecond. So we're using the ratio of power we're using to what we're putting back in the battery is a lot more. Well, not a lot more when you're talking this scale, but it's definitely drawing more current. We are putting more back into the battery, into the charge battery, but it's not as good a ratio as we had before. So the conversion rate the other way, having the diode between the two batteries, seems to be a little bit better. Not much, but it's definitely there. So myself and some others thought it would be, well, it should be much the same, but well, it is very close to being the same, but the other way seems to be a little better. So I think maybe our battery is also a resistor, so I'm just wondering, this is probably about 1.5 ohms internal resistance in the battery, so I'm just wondering if that's what's making that small difference, having the resistor before the diode instead of after the diode. So there we have it. It's not very much, but it is certainly there. So we definitely would charge the battery faster this way, but we would use more current. The other way would be a slower charge for sure, but we use a lot less current doing it. So like I said, this has nearly gone up double on the on time when you're talking in milliseconds or 0.2. So the other way it was on for about 0.23 of a millisecond, this way it's on about 0.42 of a millisecond, and the bottom of the off time is, yeah, it's exactly 0.4 of a millisecond. So it does peak down to 25 volts, 5, 10, 15 volts, sorry, not 25, 15 volts, and then levels off at about 13 volts for 0.4 of a millisecond. So a little bit of difference there, not much, but it is there. It's a slower charge set up this way, but we use less power doing it, and these are only two air cores and they're only small, and they're actually facing each other, they're not wound together. So this was by no means a powerful unit. I just had these laying around and wanted to see if it worked that way and try this new setup, so it seems to be reasonably successful. So if you're in no hurry to charge your batteries, I guess this would be alright. But the SSG style definitely charges faster, but like I said, also uses more current, as we can see there. Well, that's it from me. So I guess that's one thing explained. There is a very slight difference, it's not much, but it is there. So I might try a bifilar coil next with a core in it and pump up the amps and see if we make any difference there. Alrighty, cheers from the Tin Man.